Okay, as we talk about decimals, decimals in and of themselves, like we understand the concept. A couple of things about them, though, that we need in more detail. Decimals and their place value, separate video, okay? The decimal is that defining line and how each of those place values happen, okay? For us, we have three types of decimals that we want to talk about. I mentioned in the number types video that we have rational numbers and irrational numbers. Decimals fall into both of those categories, okay? And a lot of people kind of prefer decimals because that's what the calculator gives you when you put in a problem. It produces decimals because it's easier to write, because your calculator is not smart enough to use fractions very well. It'll give you decimals instead, okay? As well as decimals, you can always round off, whereas a fraction, it gives you such an exact answer that sometimes it's more than the calculator can handle. Calculator is only a tool, and you can use it as much as possible, okay? And if you understand how to use a tool, you're great. But if you don't, okay, I was once told, if all you have is a hammer, then everything looks like a nail, okay? Not everything's a nail. Some things require more thinking than what a calculator can do, so make sure that you don't have a dependence on that. Let's talk about these three different types. The first one that we have, terminating. Terminating decimals, terminate means to end, okay? So things like 0.25, okay? These are very nice ones that, in and of themselves, easily convert into fractions, okay? Which I'll give you a nice website as well for some of that converting. But this, when I say this correctly, it tells me the fraction. This is 25 hundredths, okay? If I say 0.25, no place value is discussed at all. 25 hundredths, now I can easily write that as 25 over 100. And now it's a fraction I can reduce and work with, okay? So that's really nice to have. All of these terminating decimals are rational numbers, okay? And so lots of these that come out, they might be a result from some of the division that you do, something like that, okay? A lot of times when we deal with decimals, it's like, oh, we need to do some rounding. Where do we typically round to? We typically round 2 spots after the decimal, okay? Why? Because that's where money works, okay? If you're not going to specify, you need to accept as far as they're willing to go, okay? I always like to go 3 or 4, because sometimes you want to round off to 3. Remember, wherever you're rounding, you go 1 farther. We'll talk about rounding a little bit more, okay? So we have terminating. Then we have repeating. Okay? So this is like 0.3 with the repeatant. That's the name for the line, the repeating line. I always just call it the repeating line. Okay? Because this is actually 0.3333333, and it keeps going forever. Okay? Now, this as well, check the website for how to convert these into fractions. 0.3, hopefully you know, is 1/3. Okay? Because if I do 1 divided by 3, I keep getting 3's as I do the division, and it keeps coming. Okay? So, a couple of details about repeating decimals. This repeatant should never cross the line, never cross the decimal point, okay? And so that's an important thing, that even if I have 1, 2, 3, 1, 2, 3, this gets the 1, 2, 3. I don't do 1, 2, 3 and then put the decimal, because then we just think it's a whole number, okay? So make sure that it's specified in there, even if that repeating pattern in 1, 2, 3, 1, 2. 3, 2, 1, 3, 1, 2 is actually the repeating set in there, okay? So these are like a power of 10 difference. We'll talk about that in your place value, okay? but understanding that that repeated line should not cross. Also, it doesn't have to come all the way up to the decimal. So it could be something like 12.03, and that 3 is repeating. Not 0303, it's 12.03333333, okay? So making sure that we use it correctly, it's not crossing over our decimal, and it's representing the parts and pieces that actually repeat. Now, some of our fractions, like 1/7, has 6 repeating digits. So you don't even get to start with your line until you do those 6 digits. So that's a whole lot of work. So as you are creating different things, think about those things. How complex can I make this, and my students will still understand and be able to do it, okay? Now, 1, 2, we need a third type. The third type originally is called non-terminating. Non-repeating. Now these are actually our irrational numbers, okay? So if it doesn't do either one of them, then it's an irrational number. Okay? Now these are hard to actually write. That's why we do some kind of symbolic representation, like pi. Pi is an irrational number. Other ones are a number that's being operated on in a way that will create the irrational number, something like the square root of 5. That is an irrational number, okay? Square roots of negative numbers, that one, go back to number types. At the very end, we talk about that. Those are imaginary numbers, not irrational numbers, okay? Irrational numbers are the square roots of non-perfect squares. So, if I had like the square root of 4, that actually equals 2. And that's not an irrational number because this is a perfect square, okay? So, remembering that this, and it has to be both of them, otherwise it falls in one of the other categories, okay? These are my irrational. Either one of these two can be written as a fraction, and those are the ones that we can convert back into regular kind of rational numbers that we see, know, and recognize what to do with, okay?